budget constraint P1 Q1 plus P2 Q2 equals Y, the horizontal intercept will be Y over P1 and Y over P2. So what would be the slope? The slope. The absolute value of the slope of this curve, it will be this height by this width, right? Is that clear? The slope of the straight line. So this one divided by this one. Then it would be Y over P2 divided by Y over P1. And it will be P1 over P2. P1 over P2. So when P2 decreases, which is the case number 1 we just talked about, when P2 decreases, what about the value, the absolute value of the slope? It goes up, right? So we just sing this as the first change. Is that right? And then in the second case, when P1 decreases, then the slope would decreases. So the first case and the second. That's why the first case makes the straight line look steeper, because with the larger slope, absolute value of the slope, so it's steeper. And then the slope, the absolute value of slope decreases, then it's flatter. Is that clear? And we will call something, or define a new term, we call it MRT, which is negative P1, P2, actually the slope with a negative sign, because the line is negatively sloping, right? So MRT is actually the slope of the budget constraint, the budget line. And we call it marginal rate of transformation, MRT. MRT is how the market allows consumer to trade one good for another. So why we call it the market allows? Why we use this verb? Because the price, P1 and P2, are the two main components of MRT, right? And P1 and P2 are market prices which are decided by market demands and market supplies of good 1 and good 2 respectively. Is that clear? So as a single consumer, we have no power over the price. We cannot affect or decide the price. We can just take it. So the market, which means a large group of consumers and large group of producers, the buyers and sellers, their interaction together decide the price. the equilibrium. Okay, so P1 and P2 are something we cannot decide, we can just take it. Which means, given P1 and P2, the market allows us to trade off something for another thing. So given this budget line, without any change of our income, so if we want to buy one more Q1, one more unit of Q1, how much should we pay additionally? If we want to buy one more Q1, the price is P1, so we need to pay an extra P1, right? But we have a constant income. We have no more P1 from besides Y. So we need to cut the consumption of good 2 so that we can afford it. Okay? So if initially we are here, we used up all our income, and now I want one more unit of Q1. Now, we cannot afford it. Is that right? Our money is not enough. We cannot just afford it. We are asked, we are required by the market to cut our consumption on good 2 so that we can satisfy the budget constraint. Is that right? So then if this is one more unit, and what about this? How many units of Q2 should we cut? If we want one more unit of Q1, we have to pay an extra expense of P1, right? And per unit of Q2, the price would be P2. So divided by P2, this is the unit of Q2 we need to cut. Is that right? Is that clear? So for example, if P1 is $200 and P2 is $50, you want one more Q1, you have to pay an extra $200. But we cannot just afford it because our income is constant. So we have to cut 4 units of Q2 so that we may satisfy the budget line, the budget constraint. Is that clear? So the reason why it is P1 over P2 is because one more unit, you need to cut 4 more units of good 2. And the slope would be 4 by 1. Is that true? Is that clear? Okay? So this is the slope, and we define it as MRT. The interpretation of the slope is how the market allows us to trade one good for another. If we want one extra unit of X1 or Q1, then we need to cut the consumption of Q2. Okay? And actually, we may just total differentiate this equation. So P1 is constant, but Q1 can be changed. And P2 is constant, and Q2 can be changed. And it equals the change of Y. But Y is constant now, right? So the change in Y would be 0. Is that clear? So dQ2 over dQ1 is the slope of the curve. right? Q2 on the vertical and Q1 on the horizontal. So Q2, P2, P2, Q2, DQ2, P1. So mathematically, in this way, in the math way, we have the same result. So either from the diagram, we have P1 over P2. From the math, we have P1 over P2. And with the interpretation of MRT, we have P1 over P2. It's quite simple results, but I want you memorize this, but not just memorize. I think with some understanding, you can remember it better, last longer. Okay, your memory will last longer. So MRT equals negative P1 over P2. So this is the budget set, the consumption set or budget set. Is that okay for you? So far we have already introduced to you something about preference, indifference curves, and something about the budget constraint. And next, I'm telling you something about optimization. So consumers maximize their well-being or utility or happiness subject to their budget constraint. The highest indifference curve, attainable, we can reach, we may have, given the budget is the consumer's optimal bundle. Okay, let's have a look at this, and then we will go back to the previous slide. So, given this the budget set or the consumption set, and we have infinitively many indifference curves, right? So, for points of this indifference curve, we love it. We prefer F to E to C to D, but we just cannot afford F, right? We cannot afford it. We cannot buy it because we do not have enough money. Is that clear? And we may consume C or D or point A. It's fine. We can afford them, but we are not satisfied because for these 3 points, they give us the utility level is not high enough. We can still pursue something better. So we try to push the indifference curve outward as possible, and then point E. This indifference curve cuts the budget line, or they are tangent to each other at point E. Okay? So, let's have a look at this. Okay. What's wrong with the indifference curve 1, indifference curve 2, indifference curve 3? What's wrong with indifference 1? Why cannot we just stay at point A or D or C? Because for this indifference curve, points on the curve provide us the same utility level, right? But points on the upper right area, points on this area provide us a better or bigger, larger utility level, right? We have some more happiness over this set. We may call that a better set. Okay? So, for any indifference curve, this would be the better set because more the better, right? So if we call that better set, and now you may see when there are some intersection of the budget line and the better set, which means within this area, points in this area satisfying two things. One, we can be better. Two, we can afford it. Something we can afford and make us better, feel happier. Of course, we may choose these points. It will be better than these 3 points, is that right? Some point within the intersection, something between this or something within this area can make us better, and also we can afford the choices. Is that right? So we would not stop at here. We wanted to pursue something better. So we just push the indifference curve outward until the interception becomes a singleton. A singleton means a set with one element only, 1 point only. Okay? Which also means when the indifference curve becomes tangent to the budget line. So in this case, if we reach this, a singleton here, just 1 point, and this curve is tangent to this line, what happened? In this case, the better set would be this one, right? And this would be the set, the consumption set or the budget set we can afford. Is that right? We can afford, we can be better. Their interception is just 1 point, which means we have no other choices given our income to make us happier, better off. Is that okay? So we call this point as the optimal choice. It becomes the optimal choice, okay? Is it reasonable? Any question here? Okay, and what is the property of point E? What is the feature or what is the characteristics of point E? The key feature is actually the indifference curve is tangent to the budget line. And we may interpret this phenomenon using mathematical terms. The indifference curve. What is the slope of the indifference curve? Do you remember that? And our marginal rate of substitution. Do you remember? Which is defined as mu1 over mu2. Most of you look like already forget it. Last week we talked about this, MRS. Let's go back. Right? MRS, the slope. Okay? So MRS, the slope of the indifference curve, must equal MR something, which is P1 over P2 we just introduced a few minutes ago. What is it? MRT. The marginal rate of substitution, which is a subjective thing, because it's about our preference, is a subjective thing. Marginal rate of substitution equals marginal rate of transformation is an objective thing, because this is what the market allows us to do, right? This is what we are willing to do. Something we are willing and something we are capable. Able. We are able and we are willing to do. They must meet each other. So the tangent thing is actually point E must satisfy this. So this is for point E. What do you think point C? Point C. You see a steeper slope of the indifference curve, right? And a flatter budget line. So in this case, the MRS, the absolute value, is greater than MRT. Is that right? Okay? And for point A, on the contrary, it's the perfect opposite case. It will be MRS less than MRT, the absolute value. This is my favorite mark. And I bought it in the US. In a museum, we call it a Snoopy Museum. I just bought it in California, northern California. North to San Francisco, yeah. All right, is that clear for you? Point E, point C, and point A. Next. Let's study the case of point E. MRS equals MRT, which means MU1 over MU2, the marginal utility of good 1 over marginal utility of good 2 equals P1 over P2. So, how do we interpret this ratio? We say, if I want to consume one more unit of good 1, the most or the maximum amount I would like to sacrifice in cutting, consuming good 2 would be MRS, right? The maximum amount, which means what? Which means the maximum amount to sacrifice, which means I would not be willing to have a lower utility level. I don't want to be worse off. So which means we need to stay on the same indifference curve. Is that right? Given the indifference curve, from here, if I want one more unit of good one, I would say, okay, this amount to sacrifice is fine for me because this point provides a better utility level. It can make me better off, right? But this amount is the maximum amount because something exceed this amount would make me worse off. So the maximum amount to sacrifice means this point provides us the same utility level as this one, which means the 2 points will lie on the same indifference curve. Is that true? Is that clear for you? Okay? So this, how we interpret this is something, if we want to consume some extra unit of good one, the maximum amount we are willing to sacrifice. Okay? So it's subjective to one subjective thing. It's about our preference, about our indifference curve. And this, in contrast, is something the market, if we want one more unit in Q1, so this is the unit we need to cut, which is decided by the market. The market allows us to, we are asked, required to cut this much so that we may afford the same thing, okay? So this point and this point remains on the same budget line. So it's about this objective one. This is what we are willing to do. This is what we are able to do. We are willing and able. Is that clear? Okay? So they should meet each other, which is the condition here. Okay? And now, I'll give you something very important, so pay attention to me, please. It's really important here. Can I rearrange this equation into mu1 over p1 equals mu2 over p2? Can I do that? Mathematically, we can, right? But does this term provide us any good interpretation? What is mu1? One extra unit of good one. The utility level, when we consume one more unit of good one, we can have, right? We may have this much utility level increased. And how much we have to pay for it? We have to pay additional P1 because we want to buy one more unit of good one, we have to pay P1. Okay? So this would be for $1, an extra dollar we spend on Q1, we may have this much utility. Once again, mu1 is for one extra unit of Q1. And one extra unit of Q1, we have to pay P1 extra money, right? So for example, if you want to have another bowl of beef noodle, so the price of a bowl of beef noodles, say $200. and after eating the beef noodle, you may be happier by, say, 400 units of happiness. 400 units of happiness. Is that clear? But for this